Hi, thank you for your interest in our work. I'm Anil, excited to present our work, Efficient Pre-training for Localized Instruction Generation of Videos. This work is done with my collaborators Davide, Laura, Marcus, and Frank. The goal of localized instruction generation has two main tasks, temporally segmenting the procedure video into key steps and generating detailed captions for each step. In other words, from an untrimmed video, we predict the temporal boundaries and generate captions for all instructions. One major challenge is the presence of noise in the pseudo labels, as prior works rely on unlabeled videos with transcribed speech and timestamps for pre-training. These transcriptions often include irrelevant content like greetings and general discussions, in addition to the key instruction information. This noise requires the use of very large dataset for pre-training to achieve effective results. The second challenge is the difference in the style between the spoken and the written language, since transcriptions come from speech. Spoken language tends to be more repetitive, while written language is generally concise and varied, leading to a mismatch. Another challenge is that previous methods use ASR text during inference, but not all videos have audio. So the models have to rely on the visual content, which makes the things even more challenging. In a nutshell, we try to address these challenges and introduce Sieve and Swap, a novel approach designed to refine the pre-training dataset and address style inconsistencies. Additionally, we present the procedure transformer, which focus only on the video modality due to the lack of ASR text during inference, and incorporates design enhancements to PDVC. By pre-training with our curated dataset using ProcX model, we achieve state-of-the-art performance on UCook2 dataset, both in fine-tune and zero-shot setting. Now let's dive into our approach, Sieve and Swap. In the current work, we focus only on the cooking domain videos. However, our approach is general and can be applied to other instructional videos. We utilize the unlabeled videos from How to 100 Million and recipe articles from Recipe 1 Million dataset. We first pair the videos with multiple recipe articles based on the content words in the title, and then compute the overlap between the transcribed speech and recipe steps. Specifically, we compute the token IOU and how many recipe tokens can be retrieved from ASR text. By varying these thresholds, we get different dataset sizes. In the current work, we focus on 50K videos for pre-training and use the paired recipe dataset to create a database of cooking instructions. To further remove the noise and bridge the style inconsistencies, we iterate over each ASR in the video and retrieve the nearest recipe step from the recipe database in the embedding space. If the retrieved step has low cosine similarity, we sieve the ASR segment. On the other hand, if the ASR segment has high cosine similarity, then a threshold, we swap the ASR segment with the corresponding recipe step, while still using the same ASR timestamp. By performing this simple sieve and swap approach, we are able to reduce the segments from 2.5 million to 0.5 million. The final curated dataset is available on Hugging Face for research purpose. To train on the curated dataset, we enhance PDVC model with key components. We use key-aware deformable attention to utilize multi-scale temporal features effectively. Second, we propose to use IOU-aware loss to improve the confidence score of predicted proposals. Lastly, we propose to use contrastive transformer with decoupled architecture inspired from the COCO model. These design choices helps to effectively utilize the video modality and parallel pre-training. After pre-training with our dataset, we see a notable increase in the performance of all models compared to using large and noisy ASR segments for pre-training. Our PROCX model achieves state-of-the-art performance on multiple metrics with UCOOK2 dataset. Additional results and ablations are available in our paper. To wrap up, our approach cleans up the pre-training dataset by removing irrelevant ASR text and bridging the style differences, achieving strong and competitive results on the instructional dataset. Thank you for listening.